Hi everyone, it's Mrs. Gifford here, and today we're going to talk about Section 06, Systems of Linear Equations. And after today, you will have reviewed how to use graphing, substitution, and elimination to solve systems of equations. So let's get right into the examples. So our first one is we're going to solve by graphing. So we're going to take a look at this problem, and we've got our two equations. We've got y equals negative 3x plus 1 and y equals x minus 3, and we're going to graph them and find the solution. So what two things do we use with linear equations? We're going to look for our y-intercept and our slope, which we use as m. If you recall back to what we talked about when we learned about linear equations, the y-intercept is always the number that's all by itself, and slope is always the coefficient of the x term. So over here on our right-hand side, our y-intercept is 1. Our slope is negative 3. So I'm going to graph that first equation by graphing our y-intercept, which is at a positive 1. And our slope is a negative 3. So from here, we're going to go down 3, right 1, and I'm going to do it again, 1, 2, 3, right 1, and I've got my 3 points, and from there I'm going to draw my line. Ooh, not a very straight line. And then I'm going to grab a second color just to keep these two lines separate, and I've got y equals x minus 3. In this case, with the second one, our y-intercept is negative 3, and our slope is positive 1. So I'm going to graph this one as well. I have a y-intercept of negative 3, so negative 1, 2, 3. And my slope is positive 1, up 1, right 1, up 1, right 1. And draw my line. Just go here and put my arrows on the bottom of my blue line. And where is the solution in this case? It's where these two lines meet. So in this case, our solution is, what's that coordinate pair? It's 1, negative 2. That would be the solution to this systems of equations. Now, quick reminder, there's two things. One, if your two lines end up being parallel, there's going to be no solution, and that should make sense because they don't intersect anywhere. And then if your two lines overlap, which means they end up getting graphed right on top of each other and it only looks like you have one line, then we say there are infinitely many solutions. Now let's take a look at the next example. In here we're going to solve by substitution. Substitution is where we take one of the equations and put it in for the other one. In this case, both equations say y equals. So I'm going to take the 3x plus 1 and replace it or put it in place of the y of that second equation. So I'm going to write 3x plus 1 equals x minus 3. Again, all I did was take the y out and put the 3x plus 1. From here, we're going to solve this. We need to get all of the x's on one side of our equation. 3x minus x is 2x. I didn't do anything with the plus 1. Bring my equal down. My x's are gone, and I have negative 3. So I have all the x's on the left-hand side. And now I'm going to get it so the x is the only thing on the left-hand side, so I subtract 1. So I have 2x equals negative 4. And I just have one step left to figure out what x equals, and I'm going to divide by 2. So we have figured out that x is equal to negative 2. Now this is not the final solution because we're talking about coordinate pairs and solving systems of equations, so we need a y value. From here, you choose one of the two equations to put negative 2 back into to solve for your x value. And as I'm looking at them, if I use the second equation, there's only one step to do, and that's to do negative 2 minus 3. Remember, subtracting a positive is like adding a negative. So in this case, the y value is negative 5. So from here, we have our coordinate pair for our solution. And it's negative 2, negative 5. So if we were to look at a graph, this is where we would see these two equations intersect. Last example. Whoops, that should not say substitution up there. That should actually say solving by elimination. Sorry about that. And in this case, to do elimination, we have to figure out a way to eliminate either the x or the y off the bat. So I'm going to just rewrite each of my two equations. I have 3x plus 7y equals 15, and I have 5x plus 2y is equal to -4. Now I want to take a look at this and see if there's opposites anywhere, because if there's opposites, I'm just going to have to add my equations once I get opposite terms in there, but I don't. It's all adding and it's all positives. So I'm just going to choose to eliminate the y values. In order to do that, I have to figure out a number that both 7 and 2 go into, 14. So I'm going to multiply my entire first equation by 2 and my entire second equation by 7. So that gives us 6x plus 14y equals 30. And 35x plus 14y equals -28. Now, the reason why we've done that is because now we have the exact same terms and we want one of these to cancel. So doing so, now we're going to subtract the entire second equation from the first, and our y's will be eliminated. 6 minus 35 is -29x equals, and 30 minus -28 is like saying adding a positive, so we get 58. And then our last step to figure out the value of x is to divide by -29. And so we get x equals -2. Now, just like the problem before, we're not quite finished. We have our x coordinate but not our y coordinate. So from here, you choose one of those two equations to put the -2 into and then solve for y. I'm just going to use the first one. So I have 3 times -2 plus 7y equals 15. And now we're just going to solve equations like we've talked about. So I have -6 plus 7y equals 15. My goal is to get y by itself, so I'm going to add 6. So I have 7y equals 21. And my last step is to divide by 7. Got to put it over here on the right-hand side. And I get y is equal to 3. So our coordinate pair, or our solution, and I'm going to put it over here on the left-hand side. Our solution is the coordinate pair -2, +3. So this is where we would see those two lines intersect. There you have it, folks, a quick review of solving systems of linear equations.